Yeah.
Not enough cash in the register.
Not enough cash in the register? Yeah. So that would be what level? What level? 5? Yeah, that would be 5. The cashier doesn't have enough cash. Yeah.
For 3, cashier registers wrong amount given to them.
The cashier, what?
Registers wrong amount given to them. Like say $100, they enter 9 into the cash register.
Oh, they make a mistake in entering. Okay, yeah, I'm making a mistake when entering the amount given by the customer. Yeah. What else? Oh, yeah.
The cashier gives the wrong amount of change to the customer.
Yeah. Wrong change back to the customer. Yeah. So that what level would that be? Number 6.
Yeah.
Number 6. What else? Yeah.
The customer gives the exact amount of money so they don't need to have change that we need.
So one of these main success scenario will not be applicable. Yeah. Exact change.
Yeah. What's wrong? Excuse me.
Yeah.
Why is that matter?
Why is that wrong? Then you won't need to have number 6. It's an alternative. It's not wrong. The question was identify the alternative or error scenario.
Isn't like 6 still applies, but the change is 0?
Give the change. Well, it depends on how you interpret it. Change. Give the change. I mean, you cannot give a change of 0, right? So then the scenario would stop at 5.
Yeah.
No? Not convinced?
No,
What else? Yeah.
The customer might change their mind and decide not to participate in that.
So here we're talking about payment. So after the pay,
No, before it's 1.
before
I
what?
see before they might change their mind and decide not to.
So that's the pay. The scenario starts when they pay, not before they pay. Like when they are about to pay. So if you have like the scenario that you're saying, the alternative scenario would be applicable to like, step 0, there's no step 0.
But they can still like change their mind before they handle it.
Yes, that wouldn't be part of this process cash payment scenario. It would be part of a different scenario. You understand? Like, something like we talked in the last one, like, indicate end of sale. So it would have to be when the end of sale is indicated and they change their mind, or in the middle. It wouldn't be when they are paying. Like, according to this, not, it might not be, ideal situation in the real world, but according to this, the customer, cannot like, because they're doing payment, they cannot go back and say, hey, I don't want this item, I don't want this item. Make sense? I know this scenario sometimes doesn't reflect reality, but we have to just go with it. I didn't write the code. Yeah.
For number 2, the customer gives counterfeit money.
Yeah, we've heard this one. We've heard counterfeit money. We've heard crumble bills, and somebody looked it up. It's called mutilated currency. Yeah, it sounds. It was rather morbid, but yeah, it's mutilated currency. And somebody else said in the previous class that as long as notes have 50% of the information, banks can still take it. So you have, basically it's less than 50% of the bill, then that would be an error scenario.
What if like the power goes out and then it's like,
The power of what?
yeah, like if the machine crashes like before they can get the
change back?
the change back, or like they lose power or something.
Well, I would, I don't know. Then somebody can say, what if there's a hurricane or an earthquake or the world crashes? I don't know about that one. It is a possibility in real life, yeah, but yeah. To be safe on the exam, write this as a real choice. If you had like, that's like an additional one, if I'm feeling generous, I want to give you some extra points.
Excuse me? So, if that's the case, how do we define other sequences? Like, where do we cut it off? At what point, like,
To what? For what?
Because anything can be an error sequence, like you were saying, hurricane hits.
No, then,
Children.
yeah, we won't say yeah, but you know, like the cashier, feels lightheaded or there's a power cut. That is like 1 million different scenarios. We try to keep it, according to, basically it should be a scenario like, that is going to affect the software, not like, the cashier doesn't like you or two people behind you start fighting or things like that. Yeah, these are real case scenario, I understand, but let's try to keep it, sort of, let's assume, there's no power cut, there's no like natural disaster happening at the same time.
Okay, so then.
Let's assume an ideal scenario for the exam,
So this
please.
should just be the first three we said. I think that cuts it.
The what?
The first three we said.
The first three?
Yeah.
What happened with
We
the first?
mentioned something about exact change, not enough cash, and wrong display. And then
Yeah, we mentioned a lot of things.
Yeah. Where do we stop it?
Oh, these are all the different possibilities. There's no stopping. I mean, we've had how many now? 8? Yeah, 8. So if there's 8, they're reasonable, that's fine. Yeah. I mean, I'm not going to ask you for 8 in the final exam. I might just ask you for like 2 alternative scenarios. If I ask you for every single possibility, you're going to spend all your time just answering one question. Yeah. We have another one?
Is there ever a scenario where the previous sale's not finished?
Based on the way it's described here, it's saying like this particular scenario is a customer is paying the total displayed by the cash. So I'm assuming they are the correct customer, like the other one
They
is
show up
done.
to the till and there's like $100 on the scan, and all of a sudden they're paying for something that's $20, and they owe $120 now. But I guess
I don't know, the cashier would have sorted this out, I'm guessing, before the customer reaches, like of course, if you go to a cash register, you bought a $20 item and they're, asking you to pay $100. I mean, I wouldn't be happy. But,
I'm kind of just trying to take it to precondition, but the precondition is that the sale's already finished, so I think I'm in the spot.
yeah, so that's the point I was making with her when she was saying, like, what if the sale is not, like the customer want to retrieve an item. So I'll assume they'll do that before they proceed to the sale, like, by the sale is finished, meaning, I decided to buy all these items and now I'm ready to pay. So the total of the items to be purchased have been displayed, yeah. So everything which is sort of before that, finding the customer, the cashier and removing items, adding items, whatever, this is all done before you actually make the payment. Because the scenario is just that part, right? Process cash payment. The customer displays the amount displayed by cash. So what are all the different things that could go wrong in a software that could affect the success scenario, meaning the sort of steps of actions that's going to happen after this particular sort of use case or scenario is activated. Like what would the software, what is the sequence of the steps of actions, sequence of actions that the software would undertake. It's very, I know, like I've seen that a lot when students answer. They don't follow the scenario, they just follow real life. I know these scenarios often don't reflect real life. Like some of these might sound like, like that's not how it happens in real life. So they start speculating and adding stuff which is outside the scenario. So try to stick, no matter how fake it is, try to stick to, what's described in the scenario. Okay? Okay, so we have 20 minutes. Hopefully that's going to be enough to go a little bit over software design. So we've talked quite a bit about software design. We talk about how, at the start of the development lifecycle, you gather the requirements, meaning you talk to your customer, you get their, you learn about what they want out of the software, what are their needs, what are their wants, and then once you have documented these requirements, maybe you are using, waterfall and you would have regular requirements. Maybe you are using Agile and you will have epics and user stories. But after this phase is done, then you move on to the next phase, which is software design, meaning you translate your requirements into design. All the courses that you've been taking so far, you didn't have to do any design. Basically, you just randomly thought, okay, what classes am I going to have? What are the attributes, what are the methods I'm going to implement? Well, in proper software engineering practices, that's not how we do things. We actually, after the requirements, we actually have some people sit down and design the entire software. By design, I'm talking about software architecture. What are the servers that we do? What are the different hardware components that we do? How are the different components of the software itself going to be related to each other? Which one are going to be connected? So they think about all of that, even before buying any sort of pieces of equipment. That's one part of software design. The other part of software design is interface. How is that website supposed to look like? How is that page supposed to look like? How is that interface supposed to look like? What colors are we going to use? How many items are we going to include in that menu? So all of these are thought even before you start implementing. Excuse me. So that's the second part. The third part is designing, and I'm just assuming sort of an object-oriented approach. The third part is thinking, okay, how am I going to break down my software into pieces? Meaning, we start thinking about packages, classes, methods, attributes, etc. So this is all the different sort of, dimensions we think about when we talk about software design. And as you can see, they have specific sort of, hierarchy, like architecture called higher level design, meaning classes, methods, and all of that, which are called class diagrams. Let's look at that in a minute. But all of these, like thinking about classes, methods, attributes, these are low level design. And normally, like I said, if you follow good software engineering best practices, and you didn't just code as you usually do without even designing the software, this is the proper step. You take the design and you translate it into software. You don't just say, okay, I need a search function, let's start coding. You actually take the search function, which is the requirement, and then you translate it into design. You even design how the page or how the interface is going to look like, and then you code. So far you have been seeing that software design phase when, in any software that you've been building. And software design, as you will see later during the semester, is actually one of the most important phases of the development life cycle. Because any decision that you take wrong here, any framework that you didn't know better, you chose the wrong framework, any sort of hardware configuration or any architecture, this is going to guide whether, for instance, you get your software scalable in the future, or you can add how many more users you can add. So a lot of the decisions, which we call design decisions that you're going to take at this step, is going to influence, how you can adapt your software to future changes. And a lot of the time we mess up this phase, so sometimes we have to start again from scratch because there's nothing much we can do. The changes that we want to implement means that we basically have to break too much. We have to change too much things. It's not, it's not even worth it. So better we start from scratch. That's why companies who know their software is going to be used for a long time or constantly increasing. For example, companies like Facebook, Meta, whatever you want to call it. The number of people using these platforms keep on increasing. TikTok, things like that. More and more users are joining these platforms every day. So they have to think, in the future. Maybe today they have 1 million. At some point in time, they're going to have 5 million. So how do we scale from 1 million to 5 million? Well, these decisions have to be taken now, not after implementation. So that's why I say it's one of the most important phase during the software development life cycle. We talk about that, how we modeling the different types of modeling the interactions, etc. So let's talk about why do we need modeling. A couple of the reasons is one of the things that modeling helps us, and I know we sort of discussed very extensively how once we gather our requirements, we validate our requirements. So you would say, yeah, it should be good by now, right? We got the requirements clear, the customer look at it and say that was fine. Well, no. When you start designing, you start finding out that, if you look at the second point, you start finding out there are issues. There are things you didn't understand. There are things you got wrong. Even the customer didn't do. So you're going to start uncovering some problem. It's going to help you better understand the requirements. Now that we start putting things together, start breaking things apart, then you're going to think, oh, between this and this, there seems to be something missing. You go back to your customer. So it helps you even refine your requirements better. Helps you find problems. Disagreements between stakeholders. Yeah, I want a search function. Nobody told you how they wanted the search function. Maybe somebody wanted just a simple, I don't know, text box for search, and somebody wanted something like a bunch of like radio buttons, so you have like multiple criteria you can select. So when you start designing things, then you start understanding, oh, yes, not all search features, search functions are the same, so you start getting, all sort of clarification. Also related to that last point, help us better understand. So here, while you're designing the software, you can ask, and of course, you're doing Agile, so your customer should be happy. Does it have all the properties that we expect? Is it doing what it is supposed to do? So you can there are multiple ways you can do that, and probably for your project, you won't be doing model animation, but for industry project, they might have the resources, the money to actually animate something and show to the customer, or maybe what you're going to do is a simple prototype, sort of a throwaway, or even like an evolutionary one, so sort of a walkthrough, show the customer some screenshots or some, some handwritten design on paper and show them, this is what it's supposed to look like. So walk them through, what you've done, and help them, and they can help you, sort of verify your understanding of the product. So if you want to understand why software design, there's their books, which can basically justify why do we need software design. So these are just a few. So you're familiar with probably most of these terminologies from 270, abstraction. So when so if you look at this diagram, there's a lot of things missing. So this is what we do in software design. We are just concerned with the big picture. We are going to do low-level things. Different diagrams have a different level of abstraction. So something like that is quite high level. I mean, maybe calculating and displaying total, it's not as simple as just calculating and displaying total. You need to get input from some sources. You need to output. Maybe you need to display it in a certain way. So it's more complicated than it looks. But in software design, we try to ignore the detail and see sort of the bigger picture. So that's abstraction. Decomposition, modularization, almost very related, meaning breaking something into smaller parts. So when you are, for example, a use case that you're drawing, you have a high-level use case. So your high-level use case would have something like process sale, would be one of the scenarios with your high-level use case. But this is a low-level use case because you're actually breaking the process sale and seeing, okay, what does process sale include? And you have all these different sort of scenarios. And even this one, you can further break it down. What does it even mean to record quantity? Where do we even record this thing? Like when you start thinking about it, because you have coded before. This is not just straightforward. You probably need a database. You need some other. It probably needs to be connected to some. When you're recording the quantity or you're retrieving the quantity, it's probably need to be linked to some stock management system. To even make a sale, do we have enough quantity? So all of that, or sometimes when you're making a sale and it's below a certain level, it automatically reorders. So these are all these sort of behind the scenes. It's not as simple as it is, depicted on the board. But it's very hard to implement everything in one go, so that's why we implement in pieces. For example, you have a university system, maybe you have a class or a bunch of classes just related to students. You have another bunch of classes related to lectures, tutorials. And then you have another bunch of classes related to everything related for exams. So, you broke down the university systems into like smaller chunks. You're not going to mix up everything and say, okay, today I'm going to work on, like a little bit of the student class, and then I'm going to skip and go to the exam class. No, you want to work on one portion at a time. Viewpoints. You've heard of this before. The model view controller. So this is another sort of dimension of software design. You can actually view design from different perspectives. Meaning a software administrator would want to see a particular view of the system that a developer might not be interested, and a developer might want to see a particular view of the system that the system architect would not be interested. So there can be different ways to depict a software product. And software design actually gives you a lot of different frameworks to view your software under different aspects. And different people are, some people are more concerned with certain view because that's what, is going to be helpful for them to do their job. So these are some of the principles for software modeling. So next, I want to talk a little bit about domain modeling, which is class diagram. So the second UML diagram we're going to look at is class diagram. So class diagram consists of entities, attributes, and relationships. And you might not be familiar with these terms, but when I say classes, you all know what a class is. Well, that's everything. It's just a fancy name for a class. Relationships are the associations, like what class is related to what class. So relationship among different classes. And attributes are, attributes, for instance, like a student has a name, an address, social insurance number, attributes of the class. That's attribute. Nothing extraordinary here. So how do we represent a class in UML? Like I told you, UML have very standard notation. You can't make up your own notation. That's why I want everybody to use a tool, so it's sort of standardized. It's broken down into these three, sort of a rectangle broken down into three parts. That too, some books or some articles or some website, you might not see the free portion. They might just have like a rectangle with the word flight on it, basically, But normally if you were to properly represent a class, this is a proper notation. So at the top you will have the name of the class, in this case this is flight. The middle part has these attributes of the class. As you can see, a flight has a departure date, departure time, arrival date, arrival time. And then at the bottom you will have the methods that this class will implement. So here you have open booking and close booking. So these are, so that means this class has 4 attributes and 2 methods. So that's how you depict a class. So you can add more information. So you can add, what you do as, like is that particular field private, public, protected, etc. You're probably familiar with all of them except derived. So derived attribute is an attribute which is calculated. So let's say I have, my birth year and the correct year, and then you would actually use 2 pieces of information to calculate my age. So age would be a derived attribute, and the way you represent that on a use case would be something like that. So whenever you see that /, that means age is a derived attribute. Okay? So same like in the start time, end time, and you want to calculate duration. So duration would be a derived attribute. They won't give you the derived attribute, they'll give you the start and end, and you have to calculate the duration. So in front of any of this, you can add these like plus, minus. So these are the sort of legend, how you represent all of them. So protected is a hash, plus is a public, minus is private, / is derived, the tilde is a default package. So next we have relationships. You have 2 types of association relationship. One is unidirectional. You can see the arrow is in one direction. and then you have bidirectional. So again, these examples might not make sense, but bear with me. The way this diagram is interpreted is, in these two classes, only one of them knows a relationship exists. Meaning a car is owned by a customer is the only way we can read that. We cannot say a customer has a car. It doesn't make sense. I know, but just trust me. The way this diagram is just a car is owned by a customer because of the arrow. Here we can say, a car is owned by a customer and a customer has a car because the arrow is in both directions. So this is the meaning of having, direct arrows pointing in a specific direction. Another variation of this, if you don't have any arrow, that also means they both know about each other. So this one can be represented also without the arrow, just a straight line, meaning the car knows about the customer knows about the car. So it's a bidirectional. So it's unnecessary in this case. Another type of relationship is composition and aggregation. So composition is that black whole diamond, and aggregation is like a hollow white diamond. So what does this mean? So composition means one cannot exist without the other. Can you have a book without pages? It's just a cover, right? There's no book without pages. So that means book cannot exist without pages. So a book is entirely made of pages. So one doesn't exist. So it's like if you don't have pages, the book died, sort of. So one cannot exist without the other. Whereas aggregation, the way we interpret this is that it is part of, like an engine is part of a car, like car door is part of a car. So that's a relationship. So yeah, just be careful. One is sort of a hollow and the other one is like a shaded black diamond. On this, I don't know if you've noticed on these lines there's also numbers. So what does these numbers mean? These numbers indicate, before we go to number, there's another type of relationship, inheritance. Inheritance is also, can also be represented in a class, class diagram. So for example, if you have different type of student, and then you have sort of student, and then you have like undergrad student, grad student, and then the sort of parent class would be student. So very similar to what you've done in, I think 270. Am I saying that right? Is that 270? Object oriented. Okay. So very similar, but it's represented using an arrow. So that's something you're familiar with. So multiplicity. Multiplicity means what? So here, one car has one engine belongs to one car. So it's just sort of a one-on-one relationship. One book has multiple pages, so that little star indicates multiple. And there's a bunch of different ways you can write them, as you can see in the sort of on the right. So 0 dot dot 1 means 0 or 1. 0 dot dot star means 0 or more. 1 dot dot star means 1 or more. You can also have specific numbers. It sounds stupid, but let's say every single human being can only have 3 dots. So then you have a specific number. Human, free. Okay, so you have a question?
Yeah, why would you use like the 0 dot dot star is a star?
Why would I have to use?
Well, no, not just like, but like, why is there 2 of them when they're the same thing?
Oh, there are different ways of writing them. You can just write, yeah. These are conventions, UML convention. So they both mean the same thing. Yeah. So basically you can, like these are just a couple of examples, but depending on your what you're going to draw for your project, you can use something similar to that. The last thing I wanted to talk about is on these lines, like you can see, you have the multiplicity and etc., and you don't have the arrows, so that means they both know about each other in terms of relationship. You can have constraints. So, for example, a person cannot be a member of the senior group unless they are like 60 years of age. So this is how you represent it in like formal UML notation using these curly braces. So you would write it sort of on the line itself. So this is called a constraint. And the thing about constraint is it doesn't only need to be in a UML diagram. In a graph diagram, as we're going to see as we go over more diagram, it can also be in other UML diagram, but it's the same notation. You have like this little curly things and then sort of a Boolean expression, inside the curly braces. Questions? We're going to stop here because we have the case study coming.